Hi there, and welcome to today's class. For this class, we'll look at the concept of calculation of solubility. Last class, we did an introduction to the idea on solubility, right? We explained its basic terms involved in the study of solubility. Also, we looked at the effects, things that affect solubility last class. So if you have not watched our video to the introduction to solubility, I'll drop a link in the video description. So check this video description. You see a link that will take you to our first class on solubility. So watch that first before you can understand this part here. So this part here is a very important concept. So understand the foundation before you come down to calculation of solubility. First things first, when it comes to calculation of solubility, I'll break this down as easy as I can. Now, your very first task here is that when it comes to calculation of solubility, there are two formulas attached to this. One formula are in the form of gram per mole. The other one there are in the form mole per dm cube. So if you have gram per mole, what formula do you apply? If you have mole per dm cube, what formula do you apply? Let's look at these two formulas one after the other. So with these two formula, you can use them to solve any problem when it comes to the concept of solubility. In our next class, we'll look at solubility curve in full detail. So I'm saying this, please. When it comes to the formulas for solubility, calculate solubility, we said there are two. Number one, the first one, I have solubility, of course, in gram per mole, so gram per dm cube, I say, gram per dm cube. So the formula is given as mass of solute over volume of solution, right? This one here in gram, this one here in cm cube, right? So times 1000. All right. So whenever your question is having gram, perhaps gram in the question, the formula to use is of course this. Now the second part there is I also have another formula for solubility, that solubility in mole per dm cube, the formula is given as mass of solute in gram over molar mass of that compound times volume of solution, of course in cm cube times 1000. These are the two mathematical expressions for solubility. In case your question, the masses are given in gram, this formula to apply, or they are given in mole, this formula you apply. So here's that. We'll solve problem. So your question determine which formula to use. So your question determine which formula to use. So I will explain that as we proceed. First things first. So note that solubility can come in gram per dm cube. The task is this: dm cube, no problem. But the task is this: gram and mole. So watch out for it, please. I'll show you how to watch out for it. For the first one there, we said for gram per dm cube, we said solubility in gram per dm cube can be expressed as mass of solute over volume of solution. Difference between this and this is that they are the same thing. It's just that this one here, there's a what? Additional molar mass times volume of solution. So in this one here, Instead of volume of solution alone, you attach what there? Molar mass first times volume of solution. And by now, you shouldn't have to get molar mass of a compound. By now, you should not to get molar mass of a compound. Alright. At this junction here, let's take an example to further explain how to apply these two formulas in solving problems. The first one was gram per dm cube. It is mass of solute over volume of solution times 100 is 1000. Number two there is that solubility in mole per dm cube is equal to mass of solute over molar mass times volume of solution times 1000. These are the two formulas attached to solubility. So note please, note, very important please, note that 1000 cm cube is equivalent to 1 dm cube. Very important please, in case of conversion. So note that 1000 cm cube is equivalent to 1 dm cube. At this junction, we'll look at sample problem. Let's take an example. Sample problem involved in the study of solubility. Question 1. If 50 grams of solute dissolves 25 grams of salt at 50 degrees Celsius, what is the solubility of the salt at the temperature? Again, I said if 50 grams of solvent dissolve 25 grams of salt at 50 degrees Celsius, what is the solubility of the salt at this temperature? First things first, your first task in science is to list out what you are given. Now listen. Last class in solubility, I explained some basic terms which involve what the solute and solvent. We said solute is simply a solid, liquid or gas, provided that it is mixed with a liquid. That is solute. We now say solvent is that liquid to which the solute is being mixed with. Alright? So here's the task, please. Check here very well. Which one is solute? Which one is solvent? It says if 50 grams of solvent is liquid, 50 grams of liquid. Alright. So the solvent is what there? 50 grams. This is my liquid, the water poured. Solvent is liquid, right? In layman, solvent for basic level is water in this guys, right? So I'm saying this solvent 50 grams dissolve 25 grams of salt. That's what salt there. We said if I have salt and water gives you salt solution, it means that salt there is the solute, water there is the solvent. In this case here, I'm given that 25 grams of salt. That's what there the solute as what there 25 grams. That's all, please. Next time it says at 25 degrees Celsius. That's temperature at what there 50 degrees Celsius. Proceed, please. It says what is the solubility? All right, solubility is unknown. First things first, what do you do? It's simple. Now look up, please. The task is this, please. We are having two expressions for solubility, this and this. If you check very well, which one will I use? Chief, check. It is simple. Do you know which I will use? I'm saying that my solute and solvent are given in what? Gram. So move that to what? Gram, not mole. Move to what? Gram. So gram per dm cube, mole per dm cube. Which one corresponds to what I'm having here? I'm not saying anything like mole in this top here. So I am not using number 2. Right? I'm so there. Number 1. Why? Because I'm having gram here. And my parameters are in gram. That's all. So in this case now, let us first now. So recall that we established that solubility is in this case here is equal to mass of solute over volume of solution, volume of solution times 1000. First things first, the task is simple. Mass of solute is given as 55. I know this. Next task, volume of solution. I don't know volume of solution in this case. So what will be the volume of solution in this case? So that's what the issue is. The task now is to get volume of solution. So how do we get the volume of solution? Write out the task. All right. So how do you get volume of solution? When it comes to volume of solution, it's more of like volume of solution. So it means that you are expecting that stuff in probably there is this place for volume of solution. It's like volume of solution. It's like it's like you mixing salt and water, and they are this. If salt and water are dissolvable, they'll give you a solution, Abi. So it means that that solution is in a bucket. So look up, please. So they are here already. Water is here and the salt are mixed together. So it's a volume of solution this way. It's a liquid. Like so they are both mixed together already. So volume of solution signifies what there? A mixture of both salt and water already mixed in a jar this way. So to get volume of solution, here's what I do, please. Volume of solution can be got this way. We know before now that density, this stuff here has to do with water, right? I have combined water and salt here. That gives you volume of solution. Now, this density is what? Mass over volume, right? We know that density is what? Mass over volume. And we know that density of water, listen. Please don't forget this, please. Very important, please. That, you that bring that in. All right, so we are saying that when it comes to volume of solution, talks about water and that solute in a jar mixed already as in this form. This is a volume solution here. Now we are at the task is simple. We have to find solubility. To find solubility, I need two things. The mass of solute is simple, is this. Next up, I need what there? Volume of solution is not given. What do you do there? It's simple. Go back to physics. We know that density is what? Mass over volume. From here, make volume, solve the formula here. That gives you that. Before then, also note this, please. Note that density of water. Look up, please. Density of water, let me call water is equal to 1000 kilogram per dm cube or 1 gram per cm cube. So density of water has two constant value. The first one is what? 1000 kilogram per dm cube, or you use what? 1 gram per cm cube. In this case, I use 1 gram because I'm saying my stuff in gram, right? And my volume, I always in cm cube. My volume is cm cube, no problem. So the type is simple. I'm using the constant value of density. Density has constant value. So the constant value of density, density has constant value. So density of water is constant. And what's the value? 1000 kilogram per dm cube, or you use what there? 1 gram per cm cube. In this case here, I'm saying that density of water, density is rho, is equal to mass over volume. Make volume subject here, because my time is to look for volume first. So volume is equal to what there? Volume is equal to what there? Mass over density. What's my mass? This mass is not any mass. This is a mass of what? Because I mixed water and salt. So the mass of what will be here? Is it mass of solute or solvent? Mass of water, solvent. So mass of solvent is 50 all over this C of water. What is of water there? 1. So we're using 1. Why are we using 1? Because 1 is gram per cm cube. And what the formula I'm using here is in gram and cm cube. So they must correspond. Alright, so volume of solution is equal to what there now? 50 cm cube. That's the volume of solution now. Gotten. Alright. Volume of solution is got. No problem. Tax now, get solubility. So solubility is equal to mass of solute is 25 all over volume of solution is 50 times 1000. All right. If I multiply this and punch my calculator, this gives about, divide this 2, that gives you 0.5 times this 1000. This man, it means the solubility will be equal to 500 what? I'm using this formula, so my answer should be in this gram per dm cube cube. All right, this is how you solve this particular question in the study of solubility. That's all. So the task, what to note here is that I introduced two things new. What did I introduce? I introduced density is what? Mass over volume from physics. Go and check your fundamental quality and derived quality is there. I just brought this stuff in plain here. I also brought this stuff in plain. Density of water, you should know this by now. It is 1000 kilogram per dm cube, or use 1 gram per cm cube. So depends on your unit you are working with, determines which value to use, right? And I use 1 here because my stuff here, I use 1 gram per cm cube because my stuff are in gram, and then a volume of solution is in cm cube. That's why I use that value 1. All right, let's solve another question, please. Question 2. Sample problem 2. Sample problem 2. Let's do sample problem 2. All right, so let's do sample problem 2. Sample problem 2. Question 2 says, hold on please. It says 144 gram of KCl, potassium chloride, 144 gram of KCl dissolves in 1 dm cube of water at 90 degrees Celsius. Full stop, please. Calculate the solubility of KCl at that temperature. Take the mass of K, take K to be equal to 39, take Cl chlorine to be 35.5. These are the molar mass, okay? So that's all, please. All right. What formula do I use here? That's the tax, and it's simple. First is first, read the question again and list out parameters. From there, we can determine which formula to use. It says, listen please, it says 144 gram of potassium chloride. So that is mass of KCl. So the mass, that's and your mass of something is not like all the solute there, right? The solute there. That's like the solute there, right? So it says 144 gram of KCl, that's mass of KCl. That's your solute. So solute is given out there 144 gram. Proceeding, it says dissolves in 1 dm cube. All right, dissolves what the 1 dm cube. It dissolves 1 dm cube. Whatever, anything, okay, it dissolves. This mass dissolves in what? In water. And what's the volume of water there? 1 dm cube. That's what there. The solvent is 1 dm cube. All right, you know what, guys? It says dissolves in what? 1 dm cube. So that 1 dm cube is the volume, right? So volume is what there? 1 dm cube. And we said that our volume are in cm cube. So we know that 1 dm cube is something as what? 1000 cm cube. That gives you a 1000 cm cube. So my volume of solution is 1000 cm cube. In this case, they give us solute and the volume of solution. So volume of solution was given as in this case it was said to be, sorry, it says dissolves in 1 dm cube. That 1 dm cube is a liquid water, the volume of solution, right? And as soon as volume is 1 dm cube, we know that 1 dm cube same thing as what? 1000 cm cube. I have, so volume is now 1000 cm cube. It now says at 90 degrees Celsius, if you check our previous example, this temperature given there, we didn't use it. Temperature just tells you, it's just there. We're not using the formula. It just there tell you the degree of hotness. Use that in undergo, right? You just say calculate the solubility of KCl at temperature. Let's just in this case, without stressing myself, I'm given the mass of potassium, mass of chlorine. It means that this I'm given this, and I'm given, it says calculate the solubility of potassium chloride. So solubility of what? KCl. So it means that I'm not using this one here. I'm using this one. Why? Because there's mole. To find KCl, this KCl now, I need to know the mole of KCl. In this case, I'm given gram though, but observe that I'm given gram, I'm given cm cube, no problem. So I'm given I'm given gram and dm cube. This gram and dm cube. Don't use this one because it can't work. Do you know why? Because we have to find what solubility of what? KCl. And KCl is a compound on its own, right? So to find for KCl now, given a compound, and also I'm having the masses of the compound. That is what? Molar mass concept. So molar mass has to do with the compound and the mass of the element. So with these three things, 1, 2, 3, it tells you that what? We're using what? Number 2 to solve this list. So solubility, solubility equals what? The mass of solute, and that's mass of solute over molar mass, molar mass times what? The volume of solution times 1000. Here's the task please. We know mass of solute as 144. Molar mass is not known. Let's get molar mass. So the molar mass, let's get molar mass now. We know volume of solution is this 1000. So molar mass of what? Of the compound KCl. To find molar mass is simple. It's simple. The compound is KCl. For K, what's K? 39. That gives 39 plus chlorine. Cl is 35.5. So the molar mass of KCl equals, add them together, that gives you about 47.5 gram per mole, right? Gram per mole, that's unit for your molar mass of KCl. I haven't got a molar mass. The task is simple now. Molar mass is got, mass of solute is known, Volume of solution is known too. So get it done, please. So solubility from here, solubility from here is equal to mass of solute is 144. So 144 over molar mass is 74.5 times volume of solution is what? 1000, right? Times what there? Another 1000. I have this one here. So it means that my solubility here, if I put calculator, my solubility here will be given as 1.933 what? What's my unit? I use this formula, right? So mole per dm cube. So that gives you mole per dm cube. This is how you solve this question when it comes to the idea of solubility. All right. That's how you solve problem when it comes to solubility, right? So let's take question 3. Let's take question 3. Question 3. Question 3. Question 3. Question 3. Right. Question 3. Sample problem 3 says, all right, a 50 cm cube of saturated solution of potassium chloride at 10 degrees Celsius yield 18.62 gram of the dry salt. Calculate the solubility of the salt at 10 degrees Celsius. Take K as being 39, Cl as being 35.5. All right. So listen to this, please. It's simple. Listen to this, please. It says a 50 cm cube of a saturated solution, 50 cm cube of a saturated solution. So that's more like what the volume of solution, right? So volume of solution. So volume of solution is what 50 cm cube. Why? It says if 50 cm cube of a saturated solution, that's of course what volume of solution. That's it. Next task, it says of potassium chloride, that's a compound. That's a compound. So I'm using this. It's a potassium chloride is a compound. KCl is a compound. I'm using that one. At 30 degrees Celsius, yield 18.62 degree of dry salt. 18.62 gram of a dry salt. That's what the mass of salt. That's the what? Solute now. That's a solute. Mass of solute. Mass of solute is of course 18 point, what is that? 62 gram. All right. Next priority says calculate the solubility of the salt at 30 degrees Celsius. All right. Solubility is unknown. Solubility. This man is unknown. It's simple. It's clear. I'm given mass of elements. I'm given a compound there. Don't stress. Use this man. That's the difference. In this one, they'll give you mass of elements. They'll give you compound to use. Use this one. But they didn't give you. They just give you masses alone. Use this stuff. Yeah, it's clear. From here now, solubility, as we know, is equal to what? The mass of solute is known as this one here, all over molar mass of the compound. Which compound there? KCl is given for that chloride times what? The volume of solution is given as what? The 50 is here. It's clear. The only issue here is what? Get mass of what? Molar mass of what? KCl. We just got that recently in example 2. Check example 2. Give me the value. The molar mass of KCl is what? Check please. KCl is what? If I check very well, that's about 74.5 gram per mole. We just solved it earlier now, so I can't just start solving this again, right? So all three things are known. So solubility now, equals mass of solute, of course, that's 18.62 grams, 0.62, all over molar mass is 74.5 times volume of solution is 50 times 50. So it's means solubility here in this case here will be equal in value to 4.99 mole per dm cube. Why am I using mole per dm cube? Because I use this formula and the unit here is mole per dm cube. So this is how you solve sample problem 3 in the study of solubility. Assignment please. In our next class, we'll look at the study of solubility course. Yeah, in full detail. Before we go, assignment please. The solubility of KNO3 potassium 95 KNO3 at 15 degrees Celsius is 0.5 mole per dm cube. Wow. They give solubility. Calculate the mass of this salt with which deposit in 1 dm cube of a solution containing 1.96 mole per dm cube of the salt was cooled from 100 degrees Celsius to 150 degrees Celsius. They give you the molar mass of KNO3 as 101. Don't stress yourself again calculating. They have given you already 101. Alright. So, answer the question. What I have to find? We have to find mass now. Yes, we have to find mass. What do you do to find mass? In this case, you don't need more stress at all. You don't need stress. I have to look for mass. What will apply? We know that, let me just give you an hint. The formula to apply here is mass equal to what there? We know that mole is what? Mass over molar mass. To get mass, make mass subject here. Mass equals what there? Mole times what? Molar mass. This formula to use, please. What's your mole there? What's mole? Check, what's the mole given there? What's the mole given? To get the mole is simple. You know we have 2 moles there, right? They have 2 moles in that question there. We have first mole as 0.5, second mole as 1.96. So the task is to get the exact mole, subtract the 1.9 mole from the 0.5 mole. That will give you the exact value of mole, right? Because we're having the first mole was 50 degrees Celsius, second mole was 100 degrees Celsius. So which one is bigger? 100 degrees Celsius comes first before there 15 degree. That gives you 1 point to get. So these are used, please. So the total amount of mole equals 1.9 mole minus 0.5 mole. That will give you 1.46 mole. That's your mole. So in this case, 1.46 mole, yeah. Times molar mass of what compound? Of KNO3 is given as what? 101 already. Check 101 already. 101 will be here. Multiply the two of them, and that's your answer. That's all, right? And that's all. All right. So this is how you find. This is how you get. I've given a hint to leave your answer in the comment section of this video. See you guys in our next class, and welcome to Excellent Link Academy.
Hold on. Before you continue this lesson, I need to tell you something important. If you've been struggling with studying, losing motivation, or you feel like you're working hard, but your results aren't showing, this is for you. I recently released a powerful book titled The Shortcut to Academic Success. It is a simple, practical guide that shows you exactly how to study smarter, stay focused, remember more, and achieve outstanding results without stress. This book is not theory. It's a step-by-step roadmap I created after years of teaching students and understanding what truly works. Inside, you'll discover proven study techniques, exam strategies, productivity hacks, memory boosters, and secrets top students use every day. Whether you are in secondary school, university, or preparing for any exam, this book will transform the way you learn and help you reach your academic goals faster. And the best part? It costs only 2,000 Nigerian Nairas, less than the price of a snack, but the value inside can change your entire academic journey. If you truly want to upgrade your grades and finally take control of your learning, don't wait. Get your copy of The Shortcut to Academic Success today. Your future self will thank you. Before we continue this lesson, I want to share something that will make your learning experience even better. I now have exclusive channel memberships designed to help you learn faster, get direct support, and access premium content you won't find in my regular videos. The first level is the support membership. If you enjoy my lessons and want to support the channel while getting special perks, this is for you. It's a simple way to show appreciation and help me continue creating high-quality educational content. The second level is the WAEC and JAMB classes membership. If you're preparing for WAEC or JAMB, this membership gives you structured lessons, practice questions, exam strategies, and step-by-step guidance to boost your performance. The third level is the 100-level students membership. This is perfect for secondary school students who want organized, easy-to-understand lessons in physics, chemistry, mathematics, and other subjects. And finally, we have the YouTube Mastery membership. If you want to learn how to grow on YouTube, how to create content, edit videos, design thumbnails, and monetize your channel, this membership will guide you from beginner to creator. Whatever stage you are in, there's a membership designed to help you learn smarter, improve faster, and stay ahead. To join, simply click the membership link in the video description. Choose the level that matches your goals and start enjoying all the exclusive benefits. Before we continue with this lesson, I'm excited to announce that I just launched my official website, a complete learning platform designed to help you study smarter, learn faster, and access high-quality educational resources anytime you need them. On the website, you'll find several well-structured courses created to guide you step by step through the most important topics. First, we have Organic Chemistry for Beginners, a simple, beginner-friendly course that breaks down organic chemistry into easy explanations anyone can understand. Next, there are WAEC and JAMB classes, specially designed to help you pass your exams with confidence using clear lessons, solve questions, and exam strategies. We also have the Physics tutorial for Year 1 students, covering foundational concepts you must master in your first year of higher education. And for anyone who wants to grow online, there is a complete course on how to start, grow, and earn on YouTube using only your smartphone. This course gives you everything you need to begin your YouTube journey without expensive equipment. There is also a book section on the website where you can get all my educational books, including The Shortcut to Academic Success. My website is now your one-stop platform for science tutorials, exam preparation, YouTube training, and learning resources that can transform your academic and digital journey. To explore all the courses and get your copy of the books, simply click the website link in the video description.